All right. Now, I told you guys at the beginning of the year, and we've been together just about 8 or so school days. I'm a pretty honest guy. Okay, this is trigonometry. It's a higher level course. I'm glad you're signed up for it. But we get into some little details like this. We also will do some application. But again, a lot of this year is trying to dig deeper into theory so that you can understand and go a little further with application. So if you're kind of like, whoa, what's going on here? Yeah, it's not an uncommon thought for students. But make sure you keep having a good attitude. Make sure that you keep trying to understand. And of course, I want to be here to help you do that also. So, undefined. Okay, all of a sudden we kind of threw that at you. Undefined. Now, it should sound familiar when you have a zero in a denominator. That's a math no-no if you have a zero in a denominator. And Friday, we introduced 6 denominators. We introduced 6 fractions. Now, remember, you got to know those fractions. Like, you got to memorize them. Tomorrow, I'm going to be giving you, it can be the easiest quiz all year. You're just going to give the answer to all 6 of those fractions tomorrow. It's a little mini check, okay? But it's not open notes. It's not open notes tomorrow. So memorize them, okay? Spend some time saying them out loud, write them down on paper. And then when you start doing problems like what I'm having you do right now, and I ask you to, now I think this is letter A, I ask you to do something like find the tangent of pi over 2, then you feel like you have a little bit of knowledge that's already in your brain. Now, 3 pi over 2. Now, the tangent of 3 pi over 2 is really referring to the y and x value when you go to 3 pi over 2. Now, when the teacher says go to 3 pi over 2, you want to make sure that you're picturing the beloved. So we go to the unit circle, and 3 pi over 2 is this place, it's this angle. And so eventually we arrive at this point, and as soon as we discover that this point is 0, -1, now we have a y and an x value. And your y value is -1, your x value is 0. Eventually we get to a step where we say that's a no-no, that's undefined. Okay, so the tangent of 3 pi over 2 is an undefined trig value. Now, did you have to show all that stuff? It's up to you. You have to think that stuff. You have to think about the unit circle. You have to think about the point that's at the bottom. The more you do it, of course, the more comfortable you get thinking about 180 degrees. What do you think about when you get to 180 degrees? What's the x and y value at 180 degrees? What's the x and y value? Mason? Now, there we go. -1, 0. And it gets tricky. You got to keep the numbers straight. We all have to do it. So wait a minute. What's the definition of tangent again? Well, it's still y over x. So what's my y value? Well, this time the y value of 0 ends up in the numerator. That's okay. You can have 0 in the numerator. So we have the tangent being 0 over -1. And again, that's okay. That's equal to 0. So how about this last one here? The cosecant of 2 pi. That's fancy. First of all, you got to know the definition of cosecant. I want you to know it for tomorrow. It's r over y. You can look it up today, but again, the sooner that you know it, the faster these little exercises go. Now, 2 pi, bless you, is an angle. 2 pi is an angle. Okay, you got to kind of know from the first week of school that it's this blue angle. So we get to this blue point, and just be careful. It's 1, 0. It's 1, 0. Now, here's something that hasn't popped up yet, but did you read about it? R would have to equal 1 For all of these scenarios, let me try to write that a little bit better. R would have to equal 1 for all of these scenarios. You're on the unit circle. Okay, so now you can put a 1 in for R, and you can put that Y value of 0 in. And, well, once again, we have a 0 in the denominator. Okay, now this kind of behavior can happen. Basically, you can end up with a 0 in the denominator. And you'll see it pop up throughout the next couple lessons. Is there anything you want to ask about with these three problems? Are you sure? So how about that second little piece? Okay, did that kind of look like something from last week? Let's just go to the good old chalkboard here. Last week we spent a moment talking about positive and negative, basically values. Okay, but here's the interesting thing: tangent is actually just combining both these together, because if tangent is y over x, that's what I already have right here. I already have y over x. In other words, what happens when you take positive over positive? Okay, well, that is going to end up being my tangent answer, which will also be positive. Each one of these statements in this diagram represents y and x. Okay, again, sine is y, cosine is x. Tangent is y over x, so positive over negative. It's almost like you can just draw a little fraction bar and think what happens when you have that positive over negative. You'll have to end up with, in this case, a negative tangent. How'd this one go? You actually end up with a negative over a negative. So it was correct to say that's a positive tangent. And then this last one is going to be a negative over a positive. So we end up with another negative tangent. It is common for students to be like, okay, so what does that mean? You'll find out even in today's lesson. It simply means that depending on where I'm at, basically quadrant 1, 2, 3, 4 will depend on the type of answer that we're going to get, the type of positive or negative answer. You had some homework. I mean, that's common. We don't have homework every night, but you had some homework. How did it go? You were trying to write out these 6 answers over and over. And there were some answers at the bottom that you could check. How did you do with number 8? I just kind of feel like number 8 might be one to go over. You end up with 2 root 41, okay, because you have negative 10, 8, and you have to find the R value. Okay, if you kind of set it all up, you're basically plugging these numbers into the Pythagorean theorem, and that ends up giving you eventually your R value. Now you end up with 164 for R squared, which means that you're going to end up with the square root for R. You have to kind of be willing to find or to break down the square root of 164. There's a 4 inside of there, which is a perfect number, and there's a 41. Okay, the 4 is the one that comes out as a 2. So we end up with 2 root 41. Now it's kind of a bummer if you don't get that right, because it's going to mess up the rest of your answers. But this one's a little harder. We get 2 root 41. Let's just do like a few of these. If you do the sine of theta, that's the y value. Now the y value is 8 over r, and r is 2 root 41. Okay, we have to be aware that there's some cleanup required here. For one thing, you can reduce 8 and 2 so that you end up with a 4. So 8 over 2 turns into 4, but this root 41 can't have that down there. So what you're going to have to do is you're going to have to multiply the top and bottom by root 41. Okay, I know it makes it seem like it's getting harder, but it's actually getting simpler. So we multiply top and bottom by root 41, And when all the dust settles, you get 4 root 41 over 41. Okay, and that's just for the sign. Do you want to talk about another one out of that batch? Is there something else on the entire homework? Number 3. Now, talk to me a little bit. What part of number 3? You had some answers, but they just didn't match up? Let's see what's going on here. It helps. I appreciate you saying, here's the point for number 3. Again, we have to find the R value, so you're going to have to carefully square these, basically plug them into the Pythagorean theorem, but you have to carefully square them. Now listen, when you square negative root 3, lots of stuff disappears. The negative disappears, the root disappears, you just get 3. Looks like R is just going to equal a nice little 2, because you take the square root of 4, so we get a nice little 2. So you're bothered by like the square root in the denominator, maybe for like secant. Okay, now I'm kind of skipping to one where that's going to happen. So secant is R over X. So you get a square root in the denominator. What you want to do is you want to say, no, I got to make the square root go up to the numerator. So you multiply top and bottom by the square root of 3. You don't really need to worry about the negative, because the negative ends up just being tacked in front of our answer. But look what happened here. I still have a 2 in the top. Now there's a root 3 beside it, and there's a regular 3 in the denominator. That would be the right way to simplify that. There's nothing else that you can do. Does that help out? What else? Anything else? Okay, keep working. Actually, you're going to find out today that the concept, the lesson today, isn't the same thing, but it uses the same skills. In fact, you're going to find out that there's 3 types of problems that we do, and they all start to basically feel like the same thing. Now, the paper I gave you, and I'll do this once in a while, is, I guess you could call it some guided notes, and it's also then something that you'll be able to work on in class and maybe finish as homework. So I want to use this to do a little teaching. So keep this paper as if it's kind of notes, however you are able to stay organized. And we're even going to give you a little time to get a couple of these figured out. At least that's the goal here. Now, today, you're going to find out that you're going to be given a trig value. And that might not mean a whole lot to you, but I want to say that language, because if you're given a trig value, okay, what you're going to first need to do is identify exactly what you know about its related triangle. About its related triangle. And you can fill in the word triangle there, but the main thing is that you're going to have to figure that out. What triangle do I know? Now, I haven't shown that to you yet, but you're going to find out that it starts to feel like something that we've already done. Now, the quadrant where theta is located is going to be a big deal, because it's going to tell you which sides of the triangle are positive or negative. It's going to tell you which sides are positive or negative. And I just kind of put a positive negative symbol in that second blank. All right. Look at letter A. Okay, we did not do this Friday. Now I'm telling you that the cosine equals 8 over 17. And there's this extra statement about theta being between 0 and 90. Let's focus on the cosine is 8 over 17. If the cosine is 8 over 17, that is just mathy talk. That is mathy talk for some x, some y, or some r value. X, y, r. Now, you have to know what cosine means. You could look it up. I can tell you, like I said, tomorrow, you want to have this memorized. Cosine will always be x over r. Now, as soon as you realize that, sort of the whole world opens up. Because if cosine is x over r, that's what 8 and 17 represent. 8 represents the x. 17 represents the y. Okay, now there's nothing that you do with that yet, except that you just realize, okay, x equals 8 and r equals 17. What's this theta is between 0 and 90? Okay, well, that's talk. That's the way that you say what quadrant you're in. Because if theta is between 0 and 90, that means that the angle is somewhere in quadrant 1. The angle is somewhere in quadrant 1. Now, you just have to be okay with this, that you just kind of draw some generic angle. It's not a big deal how you draw it, as long as it's in quadrant 1. And now you can start to do what we did on Friday. That is, we can start to draw the sides of a triangle. Okay, so the sketch that we're creating is going to be what takes us through the rest of this problem. And so do you realize that there's stuff that you already know about this sketch? You know that x equals 8. Okay, so when I write an 8 down there, I'm not just like guessing. That's what x is. I know that r equals 17. So we put a 17 on the hypotenuse. Now, you should feel like that there's something you want to find. You know, you just can't wait to find it. It's the y value. We want to find y. Okay, so don't let me stop you from doing it. This is exactly what you need to do. That's a good sign if you're kind of cracking up those calculators. Okay, because most people need a little help doing 8 squared and plus y squared and 17 squared. That's all part of the program here. Now, this is kind of like what you did Friday or over the weekend, except notice now that you're solving for y. So when you end up, obviously, when you end up doing that, you want to be careful with your algebra. You know, you actually are going to subtract 64. You're going to subtract 64. And we get the number 225. Of course, 225 is y squared, so y equals 15. Y equals 15. Now, it might not really seem like a big deal for this problem, but when I write 15 right here, I want to just kind of stop and pause and make sure that things are positive and negative as appropriate. What are we talking about? Look at where your triangle is. Your triangle is in a positive position. That means x should be positive, and it was. That means y should be positive, and it is. You say, well, what else could it be? You'll find out it could be negative. It depends on where the triangle is positioned. But right now we've got some positives. Okay, now we're ready to kind of finish the problem. And I hope you don't get tired of this, but it is sort of part of the program right now. That is finding these trig values. Okay, it says to find the remaining 5. That's because we already had one of them. Okay, and as you write these down, or maybe you're copying from me, but as you write them down, Are you getting them memorized? Are you starting to remember each of these 6 definitions? Okay, I want you to, and that's why tomorrow I'm going to kind of make a way for you to prove that you know them. Okay, so sine is y over, so it's 15 over 17. We already had cosine. Tangent is y over x, so we're going to end up with 15 over 8. And then you really just flip these over. When you flip them over, you can think about the definition, or you could just flip over your other 3 answers, as long as you trust yourself. Let's try letter B. It's gonna say some other things to us. I want you to have an opportunity to maybe talk about what you think is true, but I want to do something because this is also true. As soon as somebody tells you that theta is in quadrant 3, even if you have no idea like where the rest of this problem is going to go, as soon as somebody tells you that theta is in quadrant 3, you actually can draw this angle. Now, the position of that angle then would tell me that I can draw this triangle. And as soon as you get comfortable with these triangles, the better, because I want you to notice the way that I drew it. I always drew it so that it touches the x-axis. Okay, sometimes kids will accidentally draw this blue triangle. I even hesitate to show it to you, but that blue triangle is not going to work because it touches the y-axis. So always draw your triangle up to the x-axis. But now we're ready to talk about the cosecant. I know this is new to you. I'll be happy to explain, but I'm just wondering if anybody, do you think you know something that's true? If the cosecant equals -2, how about the definition of cosecant? It's r over y. Okay, now, as I sometimes say, even if you don't know what else is going to happen, we can say that r over y is part of this conversation. R over y. How does -2 fit into r over y? To maybe ask it another way, how can we make -2 a fraction? How can we make -2 a fraction? How about we write it over 1? Right, write it over 1. Now there's one more thing here, and it does take some careful connections from some stuff we said yesterday and even some stuff today, but there's something up here that it's not right yet. It's kind of like, wait a minute, r equals -2? R equals -2? Y equals 1? Remember the little detail from Friday, Isabel?
I don't know. I was going to say it. I thought R was one, but I don't know. It's not possible.
Okay, now it's okay that it's -2 over 1, so we won't be able to just flip that. But there is something not okay about R. There's something not okay about R. I felt like you were close to it. Pass it? It's all right. Good, Chase.
Does it R have to always be positive?
R has to be positive. So what are we going to do?
Multiply by negative.
Multiply what by negative? Should I Should I just multiply it by negative and now I get a positive?
Yeah, that works. Right?
Now, if I do that, then I've kind of changed what I was given because I was given a negative 2. Now I'm saying, oh, I'm just going to make it positive 2. What about if I transfer the negative? Make sure you don't think that this is just a magic show. Make sure you understand that this is still equal to the original negative 2. It just has been, how can we say it? We've just changed where we interpret the negative. But it's still equal to the original negative 2. We've just changed where we interpret the negative. Now, look at your sketch down here. This is, at least mathematically, this is supposed to kind of be neat. Because look, guys, this sketch wanted a negative 2. Why? It's like the main thing I want you to get from today's lesson. Look at that triangle. It has to have a negative y value, right? It goes down. Okay, so like it wouldn't have made sense if I had put a 2 there. Thank goodness I can put a negative 2. What else do we have? Oh, shoot. It's not negative 2. It's negative 1. My bad. Y equals negative 1. I was getting all excited about negative 2. But it's still negative, okay, which is the main thing. Now, the R value is 2. And as a couple people have said, R is always positive. Let's find X. Let's find X. This is always part of these problems where you have to find like the third side. Even last night's homework, you had to find the third side. Make sure that you're always careful plugging into Pythagorean theorem. Okay, you should be getting x squared equaling 3, x squared equaling 3, which means that x will equal the square root of 3. X equals the square root of 3. Now, I put the square root of 3 in this diagram. I kind of hope you did too, but I hope that now you listen because it's not right yet. It's not right yet. Wait a minute. I thought we got the square root of 3. That's supposed to be x. We put that into the diagram. But it's not right yet. This is the main part of this lesson. Remember, you filled in the blanks up at the top of the paper? The quadrant will tell you what sides are positive and negative. What is the big deal about that? Well, the big deal is that you need to make this x value match its position. Look, that x value is going to the left, right? It's going to the left. So that x value is supposed to be negative. Now, can I just make it negative? Technically, down here, when you took the square root in the Pythagorean theorem, it was positive or negative. Isn't that nice? It's kind of like you can choose. So we carefully choose the negative so that our diagram is right. You'll catch on that positives and negatives matter because basically when I go down here and do the sine of theta or the cosine of theta or the tangent of theta, just like that diagram that we drew on the sideboard over here, I want my answers to be positive or negative. Let's just do sine, cosine, and tangent just because of time here. Make sure that you're thinking. I mean, I'm filling in the answers, but if you're just copying, be careful. Are you thinking about the definitions? That's all I'm doing. I'm just plugging into the definitions from Friday. The tangent of theta is not quite the way it needs to be written. I don't want that square root down there, so I got to multiply it up to the top, and the negatives cancel out. So the answer for the tangent is root 3 over 3. I thought maybe you'd have some time, not too much time, I suppose, but to maybe look at those other questions, but put them into a homework category either way, okay? But if for some reason you want to look at maybe the first problem, because there is a minute or two here if you want to do that, I'm happy to talk to you. There are some answers on the back.